I have the honor of introducing our speaker, Gregory Simer, who is Chief Technology Officer at Northrop Grumman. He started his career in the telecom industry and then joined Northrop 22 years ago.
Yeah.
And rose the ranks from systems engineer to program director to vice president working on strategic issues, and became CTO just 4 weeks ago.
I'm almost to saying it in months, right?
So
yes.
Let's start first with a congrats and a thank you for joining us. So I want to start with, part of me wants to ask what lessons you've taken from your overall career, but we're talking security today, but they obviously cross. What lessons are you taking and Northrop is taking from the various conflicts that have been going on in the world around us? Are there changes that Northrop is making in terms of what it's investing in or maybe what it's moving away from?
No, it's a great question. It's obviously a complex time in the world right now. A lot of ongoing conflicts that are teaching us a lot about the various parts of the world and the different types of conflict and how new technologies start to interact in those domains. Ukraine in specifically, there's a lot to take away from a learning perspective on pace of innovation. How can you take in new technology, things that you literally see on the battlefield at the beginning of the week, and engage and deal with it and counter it by the end of the week or the end of the month, and iterate in this rapid session. The spy versus spy almost aspect of the war right now is causing just an incredible amount of innovation and an incredible amount of innovation at the edge that the soldiers on the ground are dealing with and implementing. That's a lot to learn. The types of technologies we're seeing, it's a different type of conflict than we may have to deal with in the future. You can leverage a lot of things like quadcopters, and you're seeing fiber reels and other aspects implemented to make them counter electronic warfare, et cetera. That's not going to work if you're trying to send a quadcopter off of Hawaii, if you're looking at other regions of the world. But the amount of innovation is captivating, and we're learning a lot on how we think about investing internally. How do we increase the rate at which we implement new products, but also how do we make our products such that you can implement and roll in new software, new features, add more capability over time. We have to be careful that we don't over-index on these entrenched warfare types of conflicts that are ongoing right now, just for the very reason of the types of regions, the types of campaigns that we may have to deal with in the future. But the innovation and how we implement the technology into what could be much higher end systems in the future is definitely a lesson to learn. Architectures, you asked about types of things that will drive us to invest differently. The types of architectures so that you can do those rapid innovations and implementations are really important as we look across all of our products. And as we think about digital engineering and how we bring products to market and design them, baking it in so that you can do that in the back end. You can't sprinkle it on after the fact to be able to upgrade, especially complex. Again, it may be easy with a quadcopter, but as you think about complex long-range systems, weapons, aircraft, spacecraft, you have to bake it in to start with.
Is there a technology area that you think doesn't get enough attention, but could be a game changer in the future of conflict?
Absolutely. Well, there's a lot, and the good news is right now there is a lot of eyes and a lot of innovation being injected into the A&D industry right now, which is great. It's a rising tide that's going to lift all boats and drive innovation across the spectrum. I talked about over-indexing on certain technologies. My worry and the last talk kind of hit home for me. A couple days ago, I was driving my teenage daughter home from practice, and she says to me, wow, the Wi-Fi really sucks here. I can't get Snapchat to work. There was so many things wrong in that statement that she said to me. One, we were in a car, not at home, that sells how those comms work. I need to do some explaining with her. But it was also a result of the AWS issue that we talked about. But it hit home for me in that we take for granted connectivity. We take for granted the data that's out there. And when you think about long ranges, extended terrain, the tyranny of range, being able to collect data with advanced sensors is still going to be needed. We're not just going to be able to use, cell phone cameras or cheap autonomous mass if we're going to be able to get the data that we need. Comms is essential. My daughter needs better Wi-Fi in the car, but we need to be able to connect all of our platforms, our spacecraft, undersea to across all domains. Otherwise, all of these things that we're talking about with AI and data manipulation and how we pull information out of out of space is only going to work if we can move that data around, and it's only going to work if we really start exploiting the capabilities that we think about in multifunction RF apertures, in advanced cameras, infrared, advanced sensors across the entire spectrum. It's only been in the past 10, 20 years where we've actually gotten to the point where we have the ability with our foundries and microelectronics to build radar sensors and other capabilities that truly go from photons to microwaves and everything in between from a spectrum perspective. That's all that data is around us. So how do we now start ingesting that data, manipulating it, looking at it, and moving it to the right place so that we can do these challenging missions, close these long-range kill chains, create the integrated air and missile defense to protect our citizens and our homelands.
So that aspect of Foundry raises a pretty interesting to me and certainly timely question. And it's cut across a number of the sessions today, but also policy, is there has been over the last several years a growing concern and interest in securing supply chains, whether we're talking about magnets to microchips. From your perspective, working in one of the biggest defense technology companies, how do you look at the problem? What are some of the areas that you'd like to see action on?
So the word that always comes to me is scale. You can prototype anything and cobble together the parts you need to create a prototype, a cool demonstration, to showing a new technology. Being able to scale requires you to have that tip-to-tail supply chain from, energetic little materials, plastics that you create in solid rocket motors, to the steels, to the electronics, the foundry access that you need to build complex systems. We have 30 million square feet of manufacturing space. We have over 20,000 partners globally of companies we work with to integrate these complex systems. We've invested over $1 billion in our solid rocket motor business just in the past 5 years, specifically with that in mind. It's not just having the space in Utah and West Virginia where we build these solid rocket motors, and truly as rocket science, it's so much fun seeing how these systems are made and the people that work on them. But it's in all of those materials that go into it, and being able to procure them on timelines that are impactful. We hear so much that there is a need to be able to ramp, that we need a defense industrial base that can scale quickly. Largely what that means is lead times, in my mind. It is you have to be able to find the material, you have to be able to engage with the material and the suppliers and the partners, but can you manufacture these things? And really it's the sub-tier, it's the materials, it's if you have to literally mine energetic materials. Those are the longer lead time aspects that we really have to consider as we pull these complex systems together and get them out to a warfighter in a state that is cyber secured, resilient. It's able to be used in a way that isn't going to potentially cause harm to that warfighter that's going to handle that piece of equipment.
So before this talk, I'll confess, I went onto the Northrop website and I was nosing around, and you all have repeated in multiple places we call it a mission statement, motto of continuous innovation. And I'm someone who's interested in history, and that idea of continuous innovation has also been at the heart of American defense strategy. If we're thinking about, for example, how we sought to win the Cold War, continuous innovation, that. So it's an obvious good. It's nothing to be, we can't argue, no, I don't want innovation and I don't want it to not be continuous. So if that's an obvious good, whether for a Northrop, for a defense industry, for an America, what are the challenges to us achieving that obvious good?
I touched on it a little bit before, but it comes to, by the way, thanks for finding that, because it's probably in my job drawer now. So I'm glad you found that on our website. It comes to what I started with, and how do you set the pace of innovation to be faster and faster and faster. A good example of how we're doing that right now is we have an aircraft called Beacon. It's built by Scaled Composites out in Mojave. It is an autonomous test bed, optionally autonomous, which I like that term. In fact, that there's a pilot sitting in the seat. It's intended to act like an unmanned aircraft, but it gives us a vehicle with an open architecture software that uses government open architectures, a standard software development kit that we can then put autonomous AI, autonomy software, flight hardware, the critical things that you want to put into an aircraft like that, but it has a human sitting there to be able to test things that may not be ready, right? And he's there to control the aircraft if something goes awry or doesn't behave like we would expect it to. It's having all of what enables us to have that platform and be able to do these experiments is having all of those open architectures. It's being able to have a software development kit that we can hand to industry at large and say, hey, here it is. Write your autonomy software, write your AI algorithm for target identification, as an example, and put it in this context that allows them to integrate on that aircraft, test, get real flight data, which a lot of these smaller innovative companies don't have test planes that they can go use, easily access. But it allows them to get that software out there and see how it evolves, how it's going to behave. And then it also allows us to increase the partners that we've got globally. It allows us to work with new innovative companies to bring different ideas into the platform and into how we design aircraft, how we design autonomy, how we design software systems to more effectively meet the needs of the warfighter. Those are, you asked about the challenges. I think in terms of how do we mitigate the things that are going to slow us down, because ultimately the challenge is, do you have a closed system? Do you have things that don't enable us to rapidly contract, deploy, update, upgrade capability into something that we've already built? All of the things around contracting and how do we move through acquisition faster. I laud all of those initiatives to make sure that we can buy things and get things on contract faster. We just have to do it in a way that we ensure that we keep the safety, resilience, cybersecurity, cyber hardening, everything else baked into the processes that we have, but enable the innovators to move at the speed of technology.
So we are at the 11th of these forums. Right now, there is, and you referenced it, a huge amount of change going on, particularly, in technology. You reference, changes in acquisition, policy, maybe even reform. You also talked earlier about there's a lot of attention, incitement, investment going on in the defense economy, including from a lot of different sources. We've got the established companies also re-looking at themselves. So imagine we're at doing the math in my head, really hard math, 16th one of these forums. What, if we're looking at the state of the defense industry, say 5 years out, what will be the same? What will be different?
It's a great question, and I reflect on my career, and I mentioned I started in the telecom industry in the 90s. I worked for a startup, saw it do this, saw it do that. It was very much during the time of the internet expansion of a lot of venture capital dollars coming in, because there is an entire new market, entire new arena that has demand signals. And then as we met capacity, as fiber got to everybody's doorstep, as we all had high speed at home, the VC money pulled out. It's great when it's here. It accelerates. I mentioned it. It's a tide that raises all boats, because it accelerates innovation. It accelerates investment across the board. We have to be prepared for a time when that venture funding may start pulling back and going to a different market. It may go to AI or something I haven't thought of yet, or any of us have thought of yet. But it's going to accelerate things, which is the great thing for defense and security globally right now. So as we think about it accelerating, how do we make sure it endures? And the technologies, the manufacturing, the sustainment of these systems are able to endure. So again, the warfighter, the equipment that he has in his hands, doesn't have a, software turns off. How many times have you bought a cool widget at home, but then the company disappears, so their app goes away, and it's the only way you can turn it on is by the app? I have like a steak thermometer thing that made me so mad. But we have to ensure that doesn't happen in our defense space, right? And that this technology can endure, and that we have the ability to make sure what's out in the field remains out in the field and effective for the warfighter and our allies globally.
Cool. Let's open it up to questions. Right there. And please wait for the mic to get to you.
Michael Nelson at the Carnegie Endowment. I do technology issues and have been for 35 years. As I look at what we've learned from Ukraine, we clearly saw the success of traditional weapons like Javelin missiles, and we've seen what drones can do. But it seems in 5 years, we're going to be paying a lot more attention to the technologies they used to ensure that their government can continue to function under attack. And that was the migration to the cloud and the tools like that Palantir and others are providing to help them understand what's going on. As you look ahead 5 years, how do you think this digital government is going to transform? And do you think we'll actually be more resilient than the Ukrainians were? Or because we'll have data in lots of places? Or are we going to have this huge attack surface and be even more vulnerable?
Yes and yes. We talked a lot, 5 years ago about JADC2 and the ability to connect everything and move data around. We're seeing that evolution now happening. I talked before about, let's not forget about communications. Let's not forget about the sensors and the information, so that we're collecting the right things to be able to give the warfighter the information he needs. But yes, 5 years from now, command and control, distributed comms is going to provide us the ability to look at different missions differently. It's not. The Homeland example you gave is a great one, and if we think about integrated air and missile defense, it's a perfect place to start applying some of these technologies and how you can take disparate sensors and make sure that we're protecting our citizens at home, or we're protecting those forward operating bases, or where our warfighters are holed up and operating out of, because you know where you're operating. It gets a lot harder when you start to project, and if we need to project power across oceans, across continents, that becomes a lot harder to make sure that you have that command and control that's truly distributed. And you may not always want it for all the reasons you brought up, and those additional attack surfaces and additional emanations that you're going to be transmitting. So it becomes a balance of what do you put at the edge, what processing do we need to ensure that can go onto our platforms or with our soldiers physically, versus how much connectivity do you put in there. And the last great talk that we heard, and making sure it is all cyber secure, and we're thinking about all of those attack surfaces up front because you cannot fix these things later. It's the one challenge and the one hesitation we have to have in trying to move fast is we can't plug these holes easily when they're out in the field and somebody needs something to work that minute.
I think we have a question from the online crowd.
Yeah, this is from Elizabeth Boyette. How do you balance protecting proprietary tech with defense industry collaboration as Northrop opens its semiconductor foundries to industry partners?
I kind of come back to there's so much innovation happening, and how do we accelerate and move fast? A lot of these processes, a lot of the things that we build, there's going to be magic sauce and expertise in them, but a lot of the things that truly matter is how you build things and how do you put these things together. And so it's different levels of how you protect proprietary. I want to collaborate with more. I want to collaborate across industry with some of the emerging new innovators that are out there, not just from the A&D industry, but across all industries. Because as we put these technologies together, and again, I'm a technologist, I want to give our kids, our warfighters, our allies, the best gear that we can possibly give them. Where I really think about IP is how do I do those things and how do I put them together, and that allows us to manage it more effectively, and how do we collaborate with others.
Great. I have a question right there in the way.
Thank you. Hi, Andy Corbett from King's College London. You've mentioned tech and venture capital and the problems with scaling. Venture capital thrives on the risks associated with innovation and the high failure rate. How does that scale into defense funding, especially if you're using public funds?
Say that again.
Well, how does that all work with public funds, which really don't like failure?
Right.
In the sense of
yes.
Defense funding. How does the public finance the scaling that is going to be required of these high-risk ventures?
No, it's a great question, and it's something, in my prior parts of my career, failure was viewed differently, and we're seeing that all over the place with emerging commercial space and other markets. We have to start thinking about these things differently and what it means when it's okay to fail and when it's not okay to fail. And once you get to the scaling perspective, that in my mind is where you can't be failing. When you have to deliver something, and I've made that shared commitment with my customer to provide them the piece of kit they need, whether it's an aircraft or it's a rocket or what have you. But failing during prototyping and development, that's where we should be doing it. That's where our internal investments are focused at trying and pushing the boundaries of capabilities. But once you get to that point of shared success being absolutely critical, that's where failure needs to be put aside. So that transition from prototype to scaling to production is really that critical crossover point.
Great. Question right here.
Hi, I'm Jack Rapansky. I'm a retired technologist and unaffiliated currently. Drilling down on your reference to over-indexing current conflicts, particularly with regard to Ukraine. So you could give maybe a few examples of when is it like really good to look at something like Ukraine as a good lens for projecting to the future, and when is it like particularly bad, and what are maybe some of the mistakes we might be thinking we're learning good lessons, but they're over-indexing?
It's a good question. I'll simplify it down to geography and the tyranny of range. So there's a lot of great lessons just around how they are scaling, how they're thinking about munitions, about the technologies they're using, and from a scaling up, whether it's unmanned platforms or other capabilities. Those are all great lessons, and those are all things that we should be looking at for our own stocks. it's in the very specific geography of the region where we have to be cautious on what kind of technologies are going to scale for broader ranges, much more complex electromagnetic environments, much different just geographies of the middle of the ocean floor versus forest and farmland. There are just unique aspects to all of these in how you collect data, how you move data, and how you think about things like strike.
I want to close with one last question, which is how you and a company like Northrop and industry goes through those kinds of calculations. Sort of in answering that question, how much are you internally wrestling with it and coming to your own conclusions versus demand signals from the customer? Are you seeing that in alignment? Are you seeing it changing? Like, take us through the inside of how you drew these conclusions from Ukraine, but where are they coming from?
No, that's a great question, and it's a combination, right? We work with partners across the entire globe, and everybody has unique criteria, unique requirements that we can work closely with them to satisfy. But the greatest part of the job, and especially this role I'm in now, is we have 100,000 of some of the smartest employees I've ever worked with, and being able to engage with folks on these program teams that have often come from the services or have been engineers developing some of the most complex systems on the planet. We're able to make some of these trades with the smart people in the room, putting a pizza under the door, and then having those conversations with our customers and the warfighter to look at how do you solve some of these enduring problems. We've been looking at a lot of the same threats over the past decade, right? And there's a lot of opinions and thoughts in how you can solve many of these. So how we work and partner with the customer is really how we approach the problem, leveraging the experiences we've had in building complex systems that we built, but also leveraging the experiences that our customers have had in engaging in some of these conflicts or working with our allies who have.
Well, thank you again for joining us today. Appreciate it.
Thank you, Peter. This has been fun.